So welcome back once again to our live session today. So in today's video, we are going to look at measures of central tendency as a third topic under the introduction to business statistics. So if you are new on this channel, please do want to share the video, like it as well, and then subscribe to the channel so that you can always stay connected to get regular updates from us. If you're a return subscriber, thank you once again for joining us always on this live session. So let's begin the journey by looking at what measures of central tendency as a third topic under the introduction to business statistics. So you are looking at the measures of what? Central tendency. Measures of central tendency. Central tendency. Okay. So when we talk about central tendency or measures of central tendency, in simple terms, all that you are trying to say here is that it is actually various measures that help us to actually identify or locate what a data. So measures of central tendency are basically a single set of value, right, that summarize a set of what data. It tells us where to identify or locate what a data. All right. So that is the measures of our central. Generically, that is the meaning behind. It tells us where to identify or locate a set of what data and actually provide a single value that helps to summarize a set of what data. And I believe that is clear. So under the measures of central tendency, we are going to look at the following what key issues or key terms. We'll look at one as what the mean. Okay, then we'll look at what the median. All right, and then we'll talk about what the mode. But under the median, we have three categories of what how to calculate median. Sorry, the mean, and I will explain each item in that line. So under the mean, we have what the arithmetic mean. We have the arithmetic mean. We have the weighted mean. Lastly, we have what the geometric mean, and we have what the geometric mean. Okay, so under the mean, we have the arithmetic mean, the weighted mean, the geometric mean. So when we talk about mean, others most popular use of the word mean is what we call what average, right? So when we want to find the mean of a set of data, actually has to do with finding the average of that set of data. So what I want to do is to what add all the set of data and then divide by the number of what the set of data. But as I said, the mean actually have for three parts. We have the arithmetic mean, we have the weighted mean, and we have what the geometric mean. Research has shown that the arithmetic mean is the most widely and reported what central measure of central tendency and the mean that is being used widely and reported by what majority of people around the world. That is what research is saying, that we make use of what the arithmetic mean being widely used and widely reported what set of what measure of central tendency. Okay, so under the mean, we're going to discuss the arithmetic mean, the weighted mean, and geometric what mean. Okay, so we begin by looking at what the arithmetic mean of a set of what data. So let's talk about the arithmetic mean. Let's talk about the arithmetic mean. So under the arithmetic mean, we are going to engage in two calculations. We are going to look at what a population arithmetic mean and then a sample arithmetic mean. Right? So we're going to look at the population arithmetic mean and the sample arithmetic mean. So by now, I know that you know what is a population and what is a sample. From the introduction to the course, we did mention of some key terms associated with what statistics, and we talk about population and we talk about the sample. So if you haven't watched that, let me just give a brief gist about these terms we are trying to bring on board. When we talk about population, population has to do with what a complete set of data that we want to what study. All right, or we talk about the entire set of data that we have interest in studying, right? But when we talk about a sample has to do with part of the population that we have an interest on, or part of the population that we want to use to make draw conclusion about the entire world population. That is the difference between the population and then the sampling, right? So as I said earlier, under the arithmetic mean, you're going to look at what this population mean and then that of what a sample what mean. So let's take note of that. So in line with that, this is what we're going to do. We'll start by looking at what the population what mean, and then we move on to talk about the sample what mean. So when we talk about population mean, in simple terms, population mean in general is what the summation of what all the data value divided by the number. So under the population mean, we will say that it is a summation of what all we use S to represent what all the set of data and then divided by what capital N or the big N. So the big N represents what? The number of what? The population what? Data. All right. So under that, under the population mean, for us to actually identify that this set of data is actually coming from the entire group or the entire set of data, then what should tell us that this population is coming from the entire set of what data? There is one property that helps us to understand that this set of data is from population or this set of data is what a sample. Under a population, there is a property called parameter. So parameter is actually a measurable characteristic of what a population. So when we talk about parameter, it is actually what is actually what a measurable characteristic of what a population. So when we talk about parameter, okay, so once you heard of parameter, then we are talking about what a measurable characteristics of what a population. That is a distinct feature of a population or the entire population we want to what, study. So let's take a note of that. So this is how we calculate a population mean. But when it comes to calculation of what a sample mean, right? Sample mean, as I use the x bar subscript x is equal to what summation of what x values divided by what n. So we use a small n to represent what the sample mean. And another sample, for us also to identify a measurable characteristic of a sample, we use a feature called what a static or a statistic. Sorry, a statistic, a statistic, a statistic. Let me write it well. A statistic. So a measurable characteristic of a sample is called what? A statistic. That's a distinct feature that helps us to identify what a set of data that is coming from what part of it is coming from what the population. That is what a sample. So let's take note of that. So as I said, generally, for us to talk about a mean, it is actually the summation of what all the data values divided by the number. So we are talking about summation of all the data value divided by the total what number under observation or under consideration. So let's take note of that. So let's take an example to actually to clarify this concept that we have built on when it comes to calculation of population mean and then the sample mean. Okay, so let's say we have this set of data. Let's say we have the following data below. Let's say the following data below shows the marks obtained by students of statistics course, right? So let's say these are the marks obtained. So example one, let's say these are the marks that was obtained by students in statistics course. So let's say we have 78, we have 74, we have 89, we have 96, we have 57, 60, 68, 91, 80, and then 75. So looking at this set of data, we are asked to what? So the question actually tells us that the following data below shows what the marks obtained by students of statistics course. So mean that we are talking about the entire student who read what statistics course, right? So here, if we are asked to find, we are asked to find what the mean. So meaning that here the mean is going to be what a population what mean, because you are talking about the entire student who study statistics. So that means that for us to find what our mean, it should be what x bar subscript p, and that should be equal to 78. So we sum up all the values under consideration, then divide by the number. So we have 78 plus 74 plus 89 plus 96 plus 57 plus 60 plus 68, okay, plus 91 plus 80, and then plus what? 75. And then divided by the total number. So let's see how many data do we have here. So we have what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 set of data here. So we have divide by what? 10. So at the end of the day, whatever you're going to get becomes what? Your population what? Mean. This is how we find the population mean. So please, in the comment section, provide an answer to this. So let me see if you actually get it what? Right. So that is how we find the population what? Mean. How about sample mean? Let's take another example. So please provide an answer to this. I'll come back and check the comment section to see if your answer is actually there. So let's talk about example 2 under the sample mean. So with the sample mean tool, we have this data. The data below shows what? A GPA of some selected students from universities across the world. So you see, immediately you hear part of set of data, we are talking about what? A sample. Because it goes like the data below shows what? The GPA of some selected students from universities across the world. So it's not all the students, but some of them. Okay, so these are the GPAs for the students across the world. We have what? Because of time, I'm not writing the data, but I'll just bring out the details. All right, that's necessary for the calculation. We have 3.5, we have 3, we have 4.0. These are the GPAs of a student. So GPA, okay. We have, so we have what? 5.0, 4.8, 4.5. Okay, we have 2.9, 3.0. We have 3.0 coming, 3.0, and then we also have 2.4. Yeah, we have 2.4. So we asked to, based on this information, we asked to calculate the mean. And what do you think is going to be the mean of this data? Since the question said some selected student, that's going to be what? A sample what? Mean. So mean that for us to find a sample mean, we say that x bar subscript what? X should be equal to, so we're going to sum up all what? The data. So we have what? Summation x divided by what? N. Here, the formula should be equal to what? Summation what? X divided by what? Capital N. Okay, so actually the calculation of the two are actually the same, but just that for us to show that whether this is a mean or popular, that's what you must tell us, or you must tell the examiner, assuming it's an examination condition. I believe that is clear. So in this plus 3 plus 5 plus 4.8 plus 4.5 plus 2.9 plus 3, and lastly plus plus 2.4, all divided by what? 9, all divided by 9. So here too, you provide an answer for us. So what will be the sample mean? So this is how we calculate a sample. But note that what we are doing here is for an ungrouped data. I should have actually mentioned that earlier. But what we are calculating, or what we want to locate the center or the central measure of such data is what? An ungrouped data. So let's take note of that. That we are talking about what? An ungrouped data. We are talking about an ungrouped data. So let's take note. Ungrouped. Ungrouped what? Data. We are talking about ungrouped data, right? Then later we'll discuss the group data in that line. So this is how we also calculate what? A sample what? Mean in that line. So let's take note of that. Please do want to like the video and share so that others will get the benefit to always to watch from this channel. That is why YouTube algorithm will push the video to others so that they can also watch from this channel in that line. So let's continue. So that is how we find what? The arithmetic mean for population, and then that of what? The sample, right? So let's take note of that. So let's move on to talk about the next thing is about the weighted what mean. So when we talk about the weighted mean has to do with what? Finding what? the average of what the set of data with their corresponding weights and then divide by the total weight. So under the weighted mean, the idea here is that each set of data values carries what a weight. And for us to find the mean of said data, we must multiply each weight by each set of data value and then divide by what? The weight. So that is what the weighted average mean actually which is about. So we have what? The weighted what mean. Okay. So the key takeaway here is when it comes to the weighted mean, each data value is being what having what a weight that's been placed on so that we can find what the mean. So in simple term, to find the mean of what a weighted values, it is always what the summation of what of the x what values, let's say xn, right? And then the weight. So it is the values of what the data multiplied by its weight, right? Just find the summation of that and then divide by what the summation of what the weight under consideration. So this is how we find what the weighted what mean. This is how we find the weighted mean in that line. So let's take note of that. So let's take an example to actually explain more of the weighted mean in that line. So the example goes like the data below shows what the number of what brands, their quantity produced, and then the hourly employees who produce such what brands. So we have a number of brands that we produce as an organization. So we have the quantity that we produce for a particular period, and then the employees who actually produce these what brands. So this is how it goes. So we have what a section for brand. So we have brand, we have the quantity produced, okay, and then we have what the hourly workers or employees, hourly workers or the employees. So we have the first one is C, the second is sax. Let me try to erase this. The third one is chi, and then the fourth one is what? Saps. So under the C we have what? 1,000. Under the sax we have what? 500. Then what is it 12? Then under the chi we have what? 1,500. And under the saps we have what? 900. And then the hourly employees actually who produce such brands are what? 15, 10, 20, and then what? 5. Okay. So this is a brand, these are the brands, and these are the quantity we produce for each brand. These are the employees who produce for such brand. So based on this information, we are asked to what? Calculate what the mean for this data. So you see that we have what the quantity for each brand, and we have what number of employees who produce that quantity. So here mean that each the data values under consideration here is what the quantity, that is the data value, but based on that we have the number of what hourly employees who produce such what. So for us to know the output we're going to actually get from these employees, you must actually what find a summation of how much quantity are produced within this number of employees within this hours that they work. Was that okay? So this is how the weighted actually weighted mean concept comes in. So for us to find the weighted mean for this set of brands of what product, we will say that weighted mean should be equal to, so that is going to be what the summation of what the product of what each quantity with each hourly employees, right? And then divide by the number of employees, hourly employees under consideration. This is how we find what the weighted mean. So we're gonna have here to be what 1,000 multiplying 15 Okay. Then you say plus 500 multiplying what 10. Okay. Then we have 4,500 multiplying what 20. And then we have plus 900 multiplying what 5. So how many brands of uh, item do we have in store? That is what 4. So we have what the data set is what 4. So then divided by, but here you can't say divided by 4 because here is there's a weight attached to each quantity of brands. So all I'm going to do is to add what the hourly employees who produce these what brands. So that's going to be what 15 plus 10 plus 20 plus what 5. Okay. So at the end of the day, just have to multiply weight each weight. So the weight is the hourly employees and the data values are what the quantities under consideration. Okay. So what I want to do is you multiply these and then add, and at the end of the day, find the division between the numerator and the denominator values, and you get your weighted mean in that line. So here to work it out for me, key this on your calculator, sum them up, and then also do the same thing here. I know 15 plus 10 is 25, plus 20 is 45, plus 5 is 50. So the denominator is what 50. So let's get this. I don't know, whatever you're going to get becomes what your weighted what mean in that line. So let me see in the comment section what the answer to this particular what question. So let's take note of. So this is how we also calculate what the weighted what mean in that line. Let's also take into the discussion further to look at what the geometric mean. So one key thing about the geometric mean here is that when we talk about the geometric mean, it has to do with what a set of data, right? That the goal is to find, let's say, the percentage of the data values. We want to know the ratio of said data values. We also want to know the growth rate of said data values. For example, let's say you engage in an investment, right? Let's say from, let's say 2000 to, let's say, 2022, right? You started with such amount and you have gotten a different amount in the year 2022. So you ask yourself, by how much has my investment grew from 2020, from 2000 to 2022? By that way, you can't use arithmetic mean to calculate that. You can't use what the weighted mean to calculate that. But we want to know the rate of growth. So if you want to know the rate of growth, then we go by using what the geometric what mean. So this is how the geometric mean also come into what play, right? So geometric mean has its application in business and in economics, where you want to find the percentage change of what certain what data or certain what items. We also want to know the growth rate of said data. We also want to find the ratio that exists between two sets of data and other issues. So this is where the geometric mean also what comes in when it comes to uh, finding the mean of such data. Okay, so that is a geometric what mean in that line. So if you want to know the percentage change of what set of data, you want to know the ratio of set of data. You also want to know even the index, and you also want to know the growth rate of what an activity like an investment or any other issue that you want to take into consideration. That's where the geometric mean comes in. So let's take an example to actually clarify the issue under geometric mean. So under that, the geometric mean have for two formulas in calculating what it mean. We have, so you let's see the formulas under consideration. So we have the first one. So I'll call it as what GM, being the first formula of calculating what the geometric mean, which is always what the end fruit of what the end fruit of what the summation or the product of, sorry, the product of what the data values under consideration. So the end fruit of, let's say, x1 multiplying, let's say, x2 multiplying, let's say, x3. Okay, let me take this off. Let's say x3 multiplying, let's say, 3 thus multiplying what x bracket n. There's one way of what calculating what a geometric what mean. But another way here is where we want to know the growth rate of a particular what activity, like an investment. We want to know how much you have made a profit from one period towards another. In that round, you can't use this formula, but you're going to use this formula. So I call it as our geometric mean formula 2, and that is always what the end fruit of what the value of the activity at the end, okay, and then divided by the value of the activity at start. So value at end, and value at start. Okay, minus 1. The minus is not within the square root, right? And then multiply all by what? 100. So this is another way of finding what a geometric what mean. Here you want to know the rate of growth that has occurred for a particular activity. So we use the value, the end fruit of the value at end of that activity divided by the value at start minus 1, which is not within the square root, and all multiplying what? 100. So let's take note of these two formulas going forward. So at any time you see any set of data that has a relation, finding percentages, finding ratios, indices, or the growth rate of such activity, then we use what the geometric word mean. If you have any question, please drop in the comment section before we get it on. So do what to like the video and share so that others will get a benefit to always to join in that particular case. So let's take an example on these two set of formulas so that we can get our way on with the main uh, measure of central tendency. So we have what? A question like, so this is going to be an example. Going to be an example for. So the percentage increase of 5 product lines of despite group of companies for the year 2021 were as follows. The percentage increase of what 5 product lines of despite group of companies for the year 2021 were as follows. So these are the products. So we have what? We have the product, and we have what? Their percentage what increase. We have their percentage increase. So we have product A, okay, we have product B, we have product C, we have product D, and we have product what? E. And these were their percentage increases. So we have product A was what? 4%, product B is 10, product C was 15, product D was 6, and then product E was what? 8. So you see this set of data. You ask yourself, which formula are you going to use, the first formula or the second formula? The second formula deal with what? Periods, right? From one set of period to another period. But here we have what? The percentage increase. Hello? I hope I can be heard. My mic went off. So here, the issue here is that you can't use the second formula to find what the geometric mean, but you can use what the first one, because we are not talking about the period. We're just interested in the percentage increase of what different brands of what product. But where the emphasis is on such one activity or one set of data, then that's where the periods will come in. We make use of what the second formula, value at the end divided by the value at the start, all in n fruits minus 1 multiplied by what? 100. So let's take it. So here, to find the geometry is going to be you're going to make use of for the first what formula. Okay. So in that line, this is what we're going to do. We'll say that the geometric mean is going to give us what? The first formula, which is what? So how many items do we have here? We have what? One, two, three, four, five, right? Five items under consideration here. So that's going to be what? The n fruit of what? So that's the n is going to be what? Five, right? Okay. And then within is going to be the increase in this product or changes in this product lines that we have in despite group of companies. So we have what? Four multiplying what? These are percentage change that line. So 10. So we have 4 multiplying 10, multiplying what? 15, multiplying what? 6, multiplying what? 8. Okay. So that's what we're going to do. So in this particular case, when you find what? The product of these what? Values, you make sure you don't bring the percentage within the bracket. Just deal with the raw what? Values. So when you multiply 4 by 10 by 15 by 6 by 8, you should be able to get what? 28800, right? And we find the n fruit, sorry, the fifth fruit of what? 288. So it's fifth fruit, right? Of 28,800. And what are we getting? With my case, with this particular guy, I provided an answer today. So we had 7.796. So an approximation on one decimal place, you should be able to get what? 7.8. So meaning that the percentage increase overall on these what? Five product lines in despite group of company the year 2021 were what? 7.8%. This is just a question to explain the geometric mean, not necessarily that these values are actually was obtained from the despite group of companies, just to appreciate the concept we are trying to build on board here. So let's take note of that. That's how we calculate such values in terms of their percentage as a whole, right? So that is the first formula that's been exhausted or used with the formula. So we can also as well take this question. Let's look at example 5. If you have any question, please do all to drop in the comment section so that we take it from there. If you haven't liked the video, like it as well. Others will get a benefit to always to watch from this channel. Okay, so for example 5, it goes like, so this one, let me write it so that we can all have it. It goes like, Veronica started an investment. Veronica started an investment, an investment in the year 2000 with an amount of $1,000. Asset, full stop. So asset the year as at the year 2022, the investment has grew. The investment has grew to $5,000. 5,000 what? Dollars. Okay. So the question here, you are asked to find the growth rate of this investment. Find the growth rate. Find the growth rate of this investment. Please don't mind my handwriting, okay? Let's just stay focused. We are asked to find the growth rate of this investment. Okay, so here you see she started the investment in the year 2000, but with the amount of $1,000. But as a year 2022, the investment was worth what? 5,000. So we are asked to find the growth rate of this investment. So meaning that here we want to know how much change has occurred from 2000 to the year what? 2022. And in that, we want to know the percentage change in that line. So here you can clearly see that these are between the periods. So we can't make use of the first formula. We're going to use what? The second word formula. So that will mean that for us to find solution should be equal to what? The end fruit of what? The value at end divided by the value at start minus what? 1 or multiplying what? 100. Are we there? All right. So here you ask ourselves, what will be the value of n? The value of n is going to be from the year 2000 to the year 2022. So how many years have that occurred, or the investment has grew from 2000 to 2022? So that's going to be 22 years, right? So it means that we have our n to be equal to what? 22. And we have our value at the end was what? 5,000 what? Dollars. And the value at start was also what? Our value at the beginning was what? 1,000. So we say that therefore the growth rate, which mean the geometric mean, should be equal to 22 as being the root of the value at n, which is what? 5,000 divided by what? 1,000 minus 1. Okay, minus 1 or multiplying what? 100. So what are we getting at the end of the day? So with that, when I compute this alone, in the square root, and then I had what? 1.0759. So minus 1 or multiplying what? 100. So what are we get when you subtract 1 from? You should be able to get 0. What? 0.0759 and then multiply by 100. And at the end of the day, you should be able to get what? 7.59%. You should be able to get 7.59%. So approximately, if you want to run to the nearest way, that's going to be what? 8%. So mean that on the account of growth rate from 2000 to 2022, the change from $1,000 to $5,000 accounted for by what? 8% change. So let's take note of that. That means that there's what? 108%. Because the initial is 100% and the change is 8%. When we add the two, you get what? 108%. So let's take note of that. So this I also calculate the geometric mean in that line when there is what? Periods under consideration to find the growth rate, percentage change, or whatever values you ask to find. So let's take note of that. Please do what to like the video and share so that the YouTube will push the video to others also to always watch from this channel. So that is the main methods, the arithmetic mean, the weighted mean, the geometric what mean. So let's talk about, let's move on to discuss what the median. Remember what we are discussing are all what we are discussing are all what? Ungrouped data. So let's take note of that. So when we talk about median, median is actually the center of what? The data. The middle set of what? The data is what we call what? The median. Okay. So the median, the key takeaway that I need to have here is that so we know this, that when the number of sets of data is odd, in terms of the total is odd, to find the median, we say that med should be equal to what? Med should be equal to what? 1 over 2, okay, n plus 1 position. So 1 over 2 into bracket n plus 1 what? Nth position. But so here is a case where we have what? Odd number. Odd number. But if we have a median which is even, then we have what? It is what? The average of what? Such what? Two values or the number of values under consideration. So let's say we have n. So nth position, right? Nth position where we have what? Even number or even numbers in that line. So let's take note of that. This is a key takeaway you need to have when it comes to what? The median calculation of ungrouped what? Data. Okay, so let's take an example here to see how far we can go. So we have this data. We have what? So example 6. We have to find the median of the following data. We have to find the median of the following what? Data. So let's see how we find the median of this data. So we have what? 7, we have 9, we have 8, 10, We have 15, 20, 5, 4, and then 6. So we are asked to find the median of this set of data. So before you can find the median of set of data, you must first know how many set of data do we have here, and after that, you arrange the set of data in order